Hello, everyone, and welcome to a one-leaf series on game development. I'm going to assume you went ahead and watched the Getting Started video for our Draw Image plugin. If not, go do that now, otherwise a lot of this won't make sense. Um, so I already walked you through how the folder structure of our project looks. The goal of today is to walk you through how all the scripts work, so that way when you're actually trying to do some coding, you can understand what in the world you're trying to do. So if we go ahead and open where everything starts, our Draw View controller, and we'll start all the way up at the top. So our Draw View controller is basically, this is the component that is attached to our draw image. So our draw image is the actual image in which all of the drawing is contained. And attached to this image is our draw view controller. And basically the image that we're editing is this drawable image. I just made it in Microsoft Paint. It's just a 1024 by 1024 pixel image. And it really doesn't matter because at the beginning of when our code starts, this image will be basically cleared. Every pixel will be set to 0 for the RGB and alpha. So let's go ahead and dive into how the script works. So we have all sorts of variables up here, and we won't worry about them. I'll explain them as we go along. So on awake, when the script is started, we'll go ahead and grab our rect transform of the object that we're attached to. We will go ahead and grab the image. We'll go ahead and create a new instance of our model that holds all of our settings. This holds the color that we're currently drawing, this holds the line width, and this holds the transparency, as well as the undo and redo stacks, and we'll get to those later. This also initializes the reset color being the color that every pixel is set to on start to be able to clear the image. We have this initialize method, which basically initializes our draw sprite, our draw texture, and our reset colors array. And then we call reset texture that we'll get to later that basically just goes through every pixel and sets it to our reset color. So in our initialize method, basically whenever you change an image, you want to repull the sprite and the texture that we're editing, that way it's updated. As well as you want to reset the color array because that image may have a different sized sprite. And then we want to refill the color array based off of the size of that. So every frame or on update, we check for keyboard input. And this is going to look a little funky if you haven't done any sort of platform-dependent compilation before. Basically, what this is saying is if this script is in, or if these lines of code are being ran inside of the Unity editor, then we will do this thing. Otherwise, for example, if we build to PC or Xbox or whatever, then these lines of code will be ran. And basically, what this is doing is instead of doing, you can see down here, instead of doing Control-Z for undo, you don't want to do that in Unity because it will actually undo what you're doing, right? So if you go to the Unity editor and you hit Control-Z, it'll undo whatever the last thing you did. So for example, if I hit Control-Z, it'll turn back on the images, right? And we don't want that to be happening as we're running and trying to do things because that'll get in the way. So basically what I changed it to was if in order to undo, you have to hold Shift and Z, and to redo, you hold Shift and Y. It's kind of a play on terminal controls. A lot of them are Control Z and Control Y. So we go ahead and check at the beginning of this if Shift is held down, if Z is held down, and if Y is held down. And you can see that for Shift we have get key. For Z and Y we have get key down. Get key will continuously give us input if the key is held down. Get key down will only give us the input on the frame that we push the key down. So we had to do this one way or the other. We can't check for get key down for both Shift and Z, and I want this function to run as soon as you hit down on either Z or Y. So if our Shift is held down and Z is held down, and we can undo, meaning we've done some drawing and there's stuff that we can't undo. I'll show you those stacks later. Then we basically set our current colors array, which is just an array of color 32 objects. Color 32 is just a wrapper on the RGBA. So a pixel is basically just a color 32, right? One pixel is basically an RGBA value, and so basically we just have an array of those. It's a one-dimensional array, but we can say if our image is a 10 by 10, then our current colors array will be 100 elements long, and we can kind of flatten that array to one dimension. So it's kind of similar for redo. If Shift and Y are held down and we can redo, then we set our colors to whatever the redo stack gives us, and then we apply those current colors. And then the only difference here is we do Control instead of Shift. Actually, we do Control Z for undo and Control Shift Z for redo, similar to how Visual Studio works. So we will skip over all this. We'll actually go to where everything starts. So all the way up at the top, we have these interfaces that we import. You can see they come from the Unity Engine's event system. You have the begin drag handler, the drag handler, and the end drag handler. So when we begin to drag, we basically want to add and undo to our stack. What this basically does is it just pushes our current state onto the stack and then clears redos, right? So if we undo, and then that adds stuff to the redos list, and then we start drawing again, we don't want to be able to redo once we've already drawn again. So we clear the redo list or the redo stack. So on begin drag, we grab the pointer event data, which is just a if you hover over it, you can just see it's an event payload associated with a pointer, either mouse or touch events. And basically, we just grab the current state of our draw texture, and we pass that in here. So on drag, this is called the frame after on begin drag. We grab the pointer event data yet again. We go ahead and create basically like an empty vector2 or a zeroed out vector2 for the local position of our cursor relative to the transform that we're in, right? So then we use the rect transform utility, and it has this nice handy dandy function called screen point to local point in rectangle. And what this does is it takes the so if you hover, sorry, we'll go by this in the way that I would normally do it as I'm coding. So the first parameter here, it takes in the rect transform that we are. So we got the rect transform in the awake method, so we can go ahead and pass in the rect transform here. The second parameter is for the screen point, and that'll be the event data, or the pointer event data up here, and we'll get the position of the mouse. So this is the position of the mouse in world coordinates. And then we'll grab the camera that we're effectively working with, so that'll be passed in with the event data as well. And then what we need is the, you see this out thing. If you don't know what that means, I would highly recommend going to check out some C# documentation. Basically what it does is, if, in fact, our point can be translated to a local point, then we are going to set this local cursor value to whatever that point is, right? So, for example, if our image is at 0, 0, we'll go ahead and pull open Unity to make this visualization a little bit easier. If our image is at 0, 0, we'll say it's at this point right here. And I want to do a rect transform. This little circle in the center of the screen is the actual pivot of the image. The pivot of the draw image itself is actually in the bottom left. You can see the pivot right here is 0, 0. And we'll get to how that coordinate transformation works in just a second. But basically this rect transform, if for example I have my mouse in the bottom left and I click, the rect transform utility will output 0, 0 because I'm relatively 0, 0 in my mouse coordinates relative to this transform, right? And if I'm in the top right, I would be 400, 400 relative to this this transform. Okay, so if we can't do this, then we'll just return because something's obviously skewed. Now we have the local position relative in not pixels, but screen coordinates. Yeah, that makes sense. So now we have to check if our cursor is even over the image, right? So this function up here will return our coordinates relative to the transform, but we want to make sure that like when we click, we are actually hovered over the image. So that way we can actually draw, right? So we basically check if our local cursor.x is less than the width, if our y is less than the height, if our x and y are greater than 0, right? So we basically check if we're between the bottom left and the top right of the image. And if that is so, then we need to transform from the local coordinates to the actual pixel coordinates, right? So we create this scale right here, the rect to pixel scale. And what this does is we grab the width of the sprite itself and we divide that by the width of the transform, right? So if our image is 1024 by 1024, and so this is a good example for exactly how this works. So the image that I'm using here, if I toggle the background ones off again, this image right here is 1024 by 1024, but the actual rect transform itself is 400 by 400. So if I'm in the top right here, the transform utility will output 400, 400, but I really want that to be 1024 by 1024. So if we multiply 400 by 1024 divided by 400, then that'll give us this top right coordinate, right? So that's the scale that we're computing here, right? So then we basically transform our local cursor. We multiply the x by the scale and the y by this scale, and then we pass that that pixel location into the local cursor. We'll go look at what this paint function does in just a second. And if we're inside of it, we'll set our previous drag position or the position that we're at this frame to where we're at. Otherwise, we'll set it to 0 because that's kind of our -1 case, for example. And then on end drag, we'll do the same exact thing. All right, so let's go to this paint function. Okay, so our paint function passes in a vector 2 in pixels, right? So if we pass in 0, 0, we want to color the pixel at 0, 0, or the most bottom left pixel. So we want to get, first of all, we want to grab the current image state, right? So we go to the texture and we say get pixels 32, which basically returns that color 32 the color 32 array we were talking about earlier. So if our previous drag position is equal to 0, meaning we weren't dragging last frame, right? So this means we basically just want to color where our mouse is. So we mark the pixels to color at our position. Otherwise, we're going to color between where we were this frame, or where we are this frame, and where we were last frame, right? So we pass in the previous drag position and our current pixel position. And then once we've marked those pixels, then we apply them. And then we update our previous drag position to where we're at now, right? Okay, so we'll go ahead and go to mark pixels to color, and we pass in that. This is basically the center pixel that we're going to color around, right? So we cast those into integers, and now we're going to loop through, and we're going to say from our center x. Let's say we left clicked and started dragging at pixel like I don't know 4, 4, right? And let's say our line width is 3. So really, what we want to go to is from 1. So we want to take 4 minus 3. So we want to color from the pixel at index 1 to the pixel at index 7, right? So we want to subtract 3 and add 3, and then loop through those in the x and y direction, right? So really what the line width is saying is this is the amount of pixels in each direction that I want to color, right? So if our pixel width, or if our line width is 1, we're going to color just the pixel that we click on. And then we have this little edge case here that we have to test for to make sure that if we're on either the most right side of the image or the most left side of the image, we need to basically make sure we don't wrap around the edge. We don't need to do that for the top and the bottom. I'm not 100% sure why that is. If one of you knows that, I would much appreciate it. So for each one of these pixels that we're looping through, we're basically going to mark that pixel to change, right? And what mark pixel does is it says we pass in an x and y, and we transform that from the actual x and y pixel position to this flattened array, right? So we basically just we multiply our width by y, and then we add x, right? You guys have worked with flattened arrays before. If this is a valid position, meaning if it's in the size of our current colors array, or if it's not inside that, then let's just determine we want to do anything with this. Otherwise, our current colors array is kind of what we're going to apply in just a second. So let's set that array position to whatever color we're currently working with. And then the other method, so that was mark pixels to color. That's when we just click, and then we start dragging. We do this color between. So we color between where we are this frame and where we were last frame. So we grab the distance between the start point, meaning where we were last frame, and the end point, meaning where we were this frame. We grab we'll say our current position is where we're at right now, right? And then we're gonna linearly interpolate. If you don't know what that means, Google it. It's fairly simple. Basically, we're gonna go from vector 1 to vector 2 in the number of steps. So basically, we want to take 1 pixel in between each one. That way, it kind of looks like it's anti-aliased, right? So basically, we lerp from 0 to 1, meaning from the start point to the end point, divided by basically the number of pixels that we need to step through. So we set our current position to the linearly interpolated position that we should be at, and then we mark that the pixels at that position. And then once we're done, we do this apply current colors thing, which basically says we grab our texture, and instead of get pixels like we have been, we just set pixels 32, and current colors is the array that we've been storing everything in, and then we apply those changes. And now we're down here finally to this reset texture thing that I mentioned in the beginning. And instead of getting the current colors that we're working with, we get our reset colors, which is just empty, straight, transparent, and then we apply those changes, which should basically reset the texture, right? And I believe that colors... Oh, I did give you some utility functions down here to... so for example, in our draw settings controller, which basically controls this panel over here and relays this information to your view controller. Rather than directly accessing the draw settings variable from our view controller, we basically have these utility functions for you to be able to call, so you aren't mucking up the um, accessibility of each of the variables. So we'll go ahead and step into our draw settings real quick. Like I said, we have the draw color, the line width, the transparency, and then we have our undo and redo stack, and these are a little funky. So when we initially create our draw settings, we basically want an empty stack. Set draw color, set line width, set alpha, these are all fairly basic. So when we add an undo, we actually want to pass in an undo or our current state, right? So let's say we just left clicked and we started dragging, right? We want to pass the state that we were in when we initially started dragging, so we can go back to that spot, right? So we add where we used to be to the undo stack, and then we clear. We do this. We only do this here, but we clear the redo stack, right? So let's say I drew a line here. Well, we will give you an example here so you can visualize it a little better. And this is going to freak out because I haven't set any of the canvas scaling. Okay, so let's say we draw one line here and we draw one line here, right? If I hit Shift Z to undo, um, if I start drawing again, I don't want to be able to redo that change, right? So I shouldn't be able to hit Shift Y and redo. You can see if I mean, you can't see the buttons I'm hitting on my keyboard, but I'm hitting Shift Y, right? And it's not redoing. And that's solely because we did this redos.clear. If we start drawing again and we add an undo, meaning like I start drawing a new line, we save the state that it was before we started drawing another line, right? And basically we want to clear that redo stack so we don't allow ourselves to redo something that we don't want to. When we actually do an undo, we kind of, for all these things, we kind of pass in the state that we're currently at, right? So we pop that undo off the stack that we had put on over here. We push the state that we're at right now, right? So this is gonna be a little bit of a pain to think about mentally, but we'll try and walk through it the best we can. So let's go ahead and this is why I didn't do Control Z. I did Shift Z. You can see I accidentally hit Control Z because I had that set up for the longest time, and it actually undoes stuff in the scene. Okay, so let's say as soon as I click down right here, right, I add an undo to the stack, and as I start drawing, nothing happens, and I let go, nothing happens. I hit Control Shift Z to undo. That should take it off the undo stack and add it to the redo stack, right? Okay, now I start drawing again. Oh crap! What if I wanted the last thing? I can't get back to there, right? I cleared the redos stack when I started drawing again. And then when I actually do my redo, so let's say I undo. When I do redo, I basically take it off the undo stack because we already put it on there, and then I push the state that we were at onto the undo stack. That way we can go back to that, right? And then to check whether or not we can undo it and redo, we just got to make sure there's there's things in the stack. I'm not going to go over the draw settings controller because that's just some basic UI code. If I do get some questions about it, I can make a short video about it, but I don't think it's terribly complicated. Basically, all it does is make sure that the UI here, whenever it updates, it sends those changes to the view controller that we've been working in, and then it updates its settings. That is about all I have for you. If I did happen to go too quickly over things, feel free to leave a comment, ask a question. I will leave the link to the Discord, the One Leaf Discord channel, so that if you do have any questions, rather than leaving a comment, you can actually hop in the Discord channel and get some more advanced help if you want to extend upon this. Yeah, thanks for watching. Appreciate it.